Okay, we're in the middle of page 4. We're going to talk about corollary. It's basically another name for a type of rule in math. So I wrote down the definition. It's a statement that can be proved easily using a theorem. A theorem is another rule. So in geometry, there's basically like the most basic rules. Those are called postulates. Those are things like two lines intersect in exactly one point, or there's only one line parallel to a given line through a given point. So those are like the most basic rules. So from the postulates, we come up with theorems, which are a little more specific. So we can use the postulates to prove the theorems. So like vertical angles are congruent is a theorem. Okay, and so from the theorems, we come up with another type of rule called corollaries. So these are more specific. Sometimes it just feels like they're just rewriting the way the theorem is written. They seem pretty obvious. If you accept the theorem to be true, then the corollary has to be true. So for this corollary to the triangle sum theorem, this triangle sum theorem was the one that said that the three interior angles of a triangle add up to 180. So the corollary says that if you have a right triangle, then the two acute angles have to add up to 90. So that's what complementary means. And at first this might look a little confusing, but if you think about it, I know all three angles have to add up to 180. And if this one, angle A right here, is 90, you only have 90 degrees left for the other two, because 90 plus 90 is 180. So my two acute angles are C and T, so I put the measure of angle C plus the measure of angle T equals 90, is what that theorem is saying. Okay, so now I want you to try this review. It does go on to the next page. There are 4 questions. Try these 4 questions and then start the video again to check your answers when you're done. So the first one says underline the correct word to complete the sentence. A polygon is a two-dimensional figure with 2 or more segments that meet exactly at their endpoints 3 or more. It's got to be 3 or more because you have to have at least 3 sides to a polygon. Okay. Cross out the figures that are not polygons. We haven't exactly talked about polygons yet, but I will say that this one is not a polygon, this one is not, and this one is not. This one's 3-dimensional. This one the sides cross, and this one you can't have rounded sides. They have to be segments. Okay. Next question, circle the triangles that appear to be congruent. Well, this triangle and this triangle look like they're the same size. Next one, write true or false. Congruent angles have different measures. That would be false. Congruent triangles have to have the same measure. Okay, so we're going to start talking about congruent polygons and congruent triangles specifically. But the definition says a rigid motion maps each part of a figure to a corresponding part of its image. So a rigid motion is back from chapter 4 when we're talking about transformations. This is anything any transformation that preserves both the length and angle measure. So there are 3 rigid motions. There's translation, reflection, and rotation. Okay, so it's anytime you take a figure, translate it, reflect it, rotate it, you've moved it around, but you've not changed any of the lengths or angle measures. So congruent polygons are going to be 2 polygons that have all the corresponding sides and angles are congruent. So I have these 2 triangles here, and I labeled the sides A, B, and C, and then D, E, and F. I want you also to label that angle A has 1 arc in it, so does angle D. So those 2 are corresponding angles. They are the same measure. So I would put angle A is congruent to angle D. Okay, F is going to go with C, so I'm going to put 2 arcs on those 2. So you can say angle F is congruent to angle C. Those are corresponding parts. And then B and E are the same. So I'm going to put 3 arcs on each of those. Angle B is congruent to angle E. Okay, so now listing the sides that are the same. It looks like this short side BC and EF will go together. So BC and EF are corresponding. This side AC is between the angles with 1 arc and 2 arcs. So it's going to go over here with between angles with 1 arc and 2 arcs. So that's that one. So that is AC will go with DF. And so then we just have the last one. That will be DE goes with AB. Okay, so we listed all 3 sets of corresponding angles, all 3 sets of corresponding sides. Okay, so a congruency statement is when you say this whole triangle is congruent to this whole triangle. So there's an important thing to remember is that you always want to list the corresponding vertices in the same order. This is something that's not difficult, but you just have to remember to do it. Always list the corresponding vertices in the same order. Okay, so the way to remember this is that it doesn't matter how you name your first triangle. So if I name the first triangle A, B, C, you just have to make sure that the second triangle is in the same order. So angle A has 1 arc in it, so we need to start with the one with 1 arc. So triangle D. Okay, B had 3 arcs, so my next letter has to have 3 arcs, so that's E. And then F and C both have 2 arcs. Okay, but it doesn't matter what order you name the first triangle. I could have said triangle BAC, and that would change the order. You'll notice I went second letter, first letter, third. So I'm going to go second, first, third again, so it'll be EDF. Okay, there are multiple correct answers. You could take both of these and make them backwards. CBA will go with triangle FED. Okay, so there's actually 6 correct answers, different ways to write it. Okay, so let's use this and look at the picture and write the corresponding parts. So AB is the slanted part, so it's got to go with the slanted part on this side. EF. BC is the long vertical one, so it's going to go with that long vertical one. It's like these are just reflected, the same figure that was reflected, so it's rigid motion. CD will go with GH. DA will go with EH. Angle A goes with angle E. Angle B goes with angle F. Angle C goes with angle G. And angle D goes with angle H. So now, we did this with this picture here, but you don't actually need a picture. So if I just have the congruency statement, I can list all the congruent parts. So the angles, we would have angle W goes with the first letter of the second one, that would be angle M. Angle Y goes with angle K. And angle S goes with angle B. Okay, and the sides. Okay, so the first side would be WY. It's the first 2 letters, so it goes with MK. Second and third letters is YS. That would go with KB. And then the first and the last letter is WS. Goes with M and B. Okay, so those are corresponding sides. Okay, so for the next one, this is the last for this video, we need to solve for X and Y in this picture. We have two congruent polygons. You'll notice that the polygon on the left doesn't have any variables. Polygon on the right only has two things marked. This angle P has an X and a Y in it, so we haven't done systems of equations, and it's not something I'm going to make us do this year. So hopefully we can solve for one of those letters first. Then here we have X minus 2, and that only has an X in it, so that's good. This is segment MQ, so looking at that, that's the first and the second letter. So it goes with the first and second letter over here, that's DE, so that's 8. So I can set X minus 2 equal to 8. Add 2 to both sides, X is 10. Perfect. So now I can substitute a 10 in here. 3 times 10 is 30, so I get 30 plus 2y. Okay. That's angle P, that's the last letter. So it has to go with angle G, that's 84. So we're going to have 30 plus 2y equals 84. Subtract 30, 2y equals 54. Divide by 2, y equals 27. And we're done. Okay, try. Let's practice some of this on your own now.